Okay, our next section in Unit 6 is going to be to change the equal sign to an inequality. So we're going to start by just graphing a single linear inequality. Basically, we're going to show the solution of a linear inequality by graphing. So the first thing we just kind of have to remember is we got to get our inequality kind of back in our head, all the language and the thoughts. So what I'd like you to do here is, we're going to be graphing inequalities, so we need them in a good form to graph. And, we love that slope-intercept form. So what I'm going to ask you to do, just to get comfortable again, this is going back to Unit 2, guys, is I want you to solve this first one for y. So you're going to transform this inequality. That x term is going to move and you're going to divide. So change this inequality so that y is isolated. Okay, let's just see how you did. Let's remember. So the first thing you should have done was to subtract the 2x from the left. And of course, it would come up as a negative 2x on the right. The only reason I'm putting it in front is because I want to see that mx plus b kind of going on over here. The second step would be to divide everybody by negative 3. And remember that when you divide by negative 3, did you guys remember the Woodruffism, the glitch? So when we divide an inequality by a negative number, or by the way, multiply, the inequality will flip. So you should have ended up with y is greater than or equal to 2/3 x minus 3. In a minute, we're going to talk about graphing that. Okay, now that you tried that one, how about number 2? Okay, did you add 3x to both sides? And did you divide everybody by positive 4 so that the inequality would not switch this time? Okay, finally, number 3. What about that one? There's actually kind of 2 ways to do this. You could have started by dividing both sides by 2 or by doing the distributive property. I did the distributive property because I kind of figured that might be the way most of you went. Then you would subtract the 10x. And then we're going to divide everybody by negative 2. And when I divided everybody by negative 2, the greater than or equal to became a less than or equal to. So I just want to remind you of that. So as we go through, if at any point we need to solve for y, the most important thing to remember is that if you multiply or divide by a negative number, the inequality switches. Okay, so today, before we get started, this is going to be an inequality that we're going to graph. And the linear inequality describes a region. It's not going to be a single point like when we solved a system of equations. Remember, we would have a single point or no solution or infinitely many. When we solve a linear inequality, we are going to see a whole region, a whole bunch of points that could be part of the solution. So it's going to describe a region, and there's going to be a boundary line to that region. Every point in the region that makes the inequality true is going to be called the solution of the inequality. So basically, I'm going to walk you through one, and then there will be a slide that gives you all the steps on like one page. So let's start this one. So the first thing we're going to do when we start to graph this inequality is we're going to graph the line. So we need it in a form that we can graph. So standard form to use the intercepts, or slope-intercept form to use that y-intercept with the slope to move. So right now I'd be plotting the y-intercept and using the slope to move to graph the line. So here is the line, y equals, in quotes, 2x plus 3. So there's the 3 of the y-intercept, and rise to, run 1. There's another point, rise to, run 1. So I drew the line in with arrows, but why did I draw the line as a dotted line? The reason I drew it dotted is because the inequality is strictly less than, which means that the points on the line don't make this true. You might remember when we did inequalities back in Unit 2 that we would have with one single variable. It was on a number line, and we'd either have a filled in circle or an open circle. An open circle meant that there was no less than or equal to component. So the dotted line is in a 2 equation in a linear function. The dotted line kind of matches the idea of the open circle, the open point. So this one is dotted. If it had been less than or equal to, I would have drawn the solid line. Now, that isn't the solution. It's all y values that are less than sort of this line. So the next thing that we're going to do is what I call test the regions. So is it all these points over here to the right of the line that would make this inequality true, or is it all the points to the left? So what I recommend that you do is you pick a point on one side or the other, and you're going to test it, like doing a check. My favorite point, of course, is the origin. So when the origin is far enough away from the line that, you can be pretty sure that it's not on the line or on the wrong side, I pick him. So I'm going to pick 0, 0, and I'm basically going to put 0 in for x in the original inequality. And I'm going to put 0 in for y, and I'm going to see if it holds true. So 2 times 0 is 0, plus 3 is 3. And since 0 is less than 3, 0, 0 is a solution. So what I'm going to do is I'm going to pick up my pencil. Eventually, we might be using colored pencils in the next unit, but we're going to shade the side that has 0, 0. If my test point comes out with a not true inequality, I would shade the side that doesn't include the test point, does not include the test point. So now every point over in this yellow region, not on the line, but every point would make this true. So if you just come over here and like 6, 1. So if I put 6 in for x and 1 in for y, I would have 1 is less than 12 plus 3. 1 is less than 15, and it works. All the points over here, however, would not work. So there's an infinite number of solutions. So here is sort of what we just did. The first thing you're going to do is you're going to graph the line as if there wasn't an inequality. So you need to have it in y equals mx plus b. Sometimes you can use standard form if those intercepts are easy to graph. Right as you're getting ready to draw the line, you stop yourself and say, should it be dotted or solid? So if it's greater than or equal to, it would be a solid line. If it's strictly greater than, it would be a dotted line. And I talk about that right here. The next thing we're going to do is you test the regions. So once you've drawn your line or dotted line, you pick a point on one side or the other. And again, the origin, it's just easy math, guys. And you test it in the inequality. And then you shade the region containing or not containing the test point. So if the test point makes the inequality true, shade the region where that point is, otherwise shade the other side. It's not that difficult at all. Okay, so the first thing we're going to do right now is I'm going to ask you to graph, this one, and we're going to answer the question, once you finish graphing this inequality, is 5, -2 a solution of this inequality? And I apologize, that should be a less than or equal to. So I'm going to fix that, and you're going to start by going ahead and graphing this one. And the question is going to be, is this good or not? So let's see how you did. So we're going to start by graphing the line. So it was already in y equals mx plus b, all right, if we put an equals in there. So there's my y-intercept, and to go up 1, 2, 3, 4, and over 1. I kind of missed that point a little bit, the way I drew the line. And it's solid because it's less than or equal to. Now, the next thing I need to do is check the shading. Now, you're going to notice here that I didn't use the origin because, it looks so close. Or it goes through, it doesn't go through it, but it looks just so close. So I picked the 0.21 over here because it was far enough from the line. 2 goes in for x, y goes in for 1. I checked it, and when I put that point in, I get 1 is less than or equal to 7, which is true. So I want to shade the side that has my test point, which would be 2, 1. So I'm going to shade over here. All the points in that yellow region, I didn't do a great job of shading them all out here, but everybody over here is going to be a solution. So now the question is 5 -2 a solution? And you should have said yes, because there it is, and it would be in the shaded region. How about this one? Can you graph y is less than 3 and answer the question, is the point 1, 2 a solution? So the first thing I notice is the x is missing. That means it's one of our special cases. And it means that every point on this line has a y coordinate of 3. It is a horizontal line through 3, dotted because the equal is missing. So now the question is, I need less than 3. And when they are the special cases, it's obvious to kind of see where to shade, but I'm just going to show you that I'm going to pick my favorite test point, and I'm going to put, just the 0 in for y. It holds true. So I'm going to shade where 0, 0 is, and it makes sense. I need all the numbers that are less than 3. All the y's less than 3 would be down here. So there is my shading. So the question is 1, 2 a solution? And you can see off the graph that it is. Oh, by the way, you can check this kind of a question by putting the x and y in the original as well. So you can see it on the graph. You could also put the 2 in for y, see that 2 is less than 3. It makes it true. So this would be a solution. Okay, so let's just do one that's not in that same form. So here you can see it's in standard form. So, can I use standard form to graph this? So, will the intercepts be easy to graph? So here comes my famous box. I'm going to let y equal 0. So 3 times 0, that's going to disappear. The inequality is 2x is greater than or equal to -12. I'm going to divide both sides by +2. It doesn't matter what this guy is. This is not the glitch. So it's going to, remember, stay. So, it would be -6. But just know that if you were solving this, you wouldn't be flipping it. So I got a -6 for the x, and it looks like a -4 for the y. So that would be one way to do it. You're going to come and plot your x-intercept of -6, your y-intercept of -4, and join them, and you'd have the line. Your choice is you could solve for y. You could subtract 2x and divide everybody by 3, and you could use the slope-intercept form. No matter which one you choose, you should get this line. So if you look at the 2 red points, there are the 2 intercepts. And then if you were to start at -4 and go down 2 and over 3, so you'll get the line either way. I drew it solid because it's greater than or equal to. So now the question is -4, 3 a solution? So if I didn't shade. I got to shade first. So I'm going to use my 0, 0. I plug it in, and 0 times x, 0 times 2 is 0. 0 times 3 is 0. 0 plus 0 is 0. So 0, is it greater than -12? It is yes. So I'm going to shade where 0, 0 is. And now I'm going to answer the question, is -4, 3 a solution? And you can see pretty easily there that it is. So that's how we solve a linear inequality. So let's go backwards. This time I'm going to give you the line, or rather the inequality with the shading, and I'm going to ask you to write the inequality. So the first thing that I kind of do is I can see the y-intercept and I can find the slope. So the y-intercept is 2, and my slope is down 1, down 2, down 3, so -3 over 2. So I'm going to start sort of with this idea. So the question is, what inequality do I put in here? So there's my y-intercept and there's my slope. So y equals mx plus b, but it's an inequality. The easy part is to know whether you should have the line, like the equals to part. And since it's dotted, my choice right now is either less than or greater than. So I make my guess of what I think it is, and I think it's going to be less than. And what you should do is do that idea of a test point again. So what if I take my 0 and I put it for x and y? 0, 0 is shaded. And since it's shaded, it should make my inequality true. If it doesn't, I've got the wrong inequality in there. So 0 in for y, And that should not be subtracted. That should be multiplied. So let's fix that. There we go. And when we multiply the negative 3/2, times 0, this will be 0 plus 2. And I end up with 0 is less than 2. That is true. My inequality was correct. If my inequality came out looking like 0 is greater than 2, I'd be like, wait a minute, that's not true. I had the wrong, inequality in there. So the only mistake, I think I just need a negative in there, right? Oh, there we go. Okay, so one last thing. Where is this used in the real world? So we're going to do a real world graph of an inequality. And to be perfectly honest, a lot of times inequalities make more sense in the real world than the equation. So, you plan to spend no more than $24. You don't think you're going to go in the store and come out exactly with no change, but you do have like an upper limit on your budget. So inequalities actually make a little bit more sense, I think, in the real world. So you plan on spending no more than $24 on decorations for a party. Streamers cost $2 a roll, and tablecloths cost $6. Graph the inequality and find 3 possible combinations that you could buy of streamers and tablecloths. Okay, so the first thing I'm going to do is come up with my 2 unknowns. So I'm going to call X the streamers and I'm going to call Y the tablecloths. To be honest, if you did the reverse, it would be fine. There's no dependency in this case. So now you could see that the X, which is streamers, is going to get attached to the 2. So it would be 2X. And the tablecloths is going to get attached to the 6. And then we've got this total. So we've got the 2X plus the 6Y, and we cannot go over 24. It has to be less than or equal to 24. So that's just like we did with equations, except it kind of makes more sense that we would not be spending exactly $24. I don't know if you can hear in the background, but Emma is officially screaming in the background. All right, so now we're going to graph this. So here comes what we've learned today. We're going to graph this inequality. Now, if it were me, I see this as a standard form. So here comes the infamous box. And if I cover over my y and take 24 divided by 2, my x-intercept would be 12. If I cover over the x, make x equal to 0, my y-intercept would be 4. So now what I need to do is come over here and make sure that my x gets up to at least 12 and my y gets up to, at least 4. So I need to kind of put the scales in here. I need to put a title. I need to put my labels. So title, labels, and scales is kind of where we're heading. So remember that the x had to get up to at least 12. So I'm going by 2s, 2, 4, 6, 8. And over here, the tablecloths, I'm going by 1s because I only had to get up to 4. Now I'm going to plot my intercepts and connect them. And notice it will be a solid segment in this case. It's not going to be a line because we're not going to talk about negative streamers and we're not going to talk about negative tablecloths. So I'm going to plot my points and connect it with a solid segment. So the next thing, because it's less than or equal to, I need to shade. We probably already have a pretty strong feeling of where the shading should go, but the point 0, 0 I could use and put in for x and y. And I'm going to get basically 0 is less than or equal to 24. So my shading is going to basically go in this triangular portion in the bottom left corner. So the whole point of doing this was to find 3 possible combinations of streamers and tablecloths you can buy. Not every single point in the yellow region is going to be good because you can't rip open like a roll of streamers and pull some of them off. So only the points on the crosshairs are going to work. If you look at the y-intercept, you could buy 4 tablecloths and no streamers and spend the $24. Or you could have 12 rolls of streamers and no tablecloths and spend the $24. And then every point on the line and in the yellow region would represent pairs, combinations of points that would work. So I'm just going to grab a dot over here. So, you know, right there, we're going to look at the crosshairs. These are all possible, you know, solutions that would give you, let's see, that one looks pretty good. That would give you combinations, and again, all of these, right? So I could go in and fill all in the crosshairs. So then I'm just picking off 3 of those, and here's 3 that I picked. So I picked the 6 streamers and 2 tablecloths, which is this one right here. I picked the 4 streamers and 1 tablecloth, which is right there. I picked the 2 streamers and like 3 tablecloths, which is right there. I mean, there are more combinations, but all of these you would leave being able to afford. And I think other than this one, you would leave with change. So inequalities are really pretty easy to solve. You either have your inequality written in slope-intercept, oh, by the way, y equals mx plus b, or standard form, ax plus by equals c, but there's going to be an inequality in there. Probably the best slide that we have here was the one that described the steps. So if you kind of go back, you remember that the first thing is you need to have it written in the right form. And then you're going to graph the line. But when you go to draw the line, you ask yourself dotted or solid. It depends on whether it's less than or equal to or greater than or equal to for solid, strictly less than or greater than for dotted. And then you pick a point on one side or the other and test it in the original inequality. If it works, you shade that side. If not, you shade the other side. The origin is a wonderful, wonderful choice. If it's not too close around the line. And then finally, you shade the side that contains that solution. So that's kind of where we're at today, is graphing inequalities. The next time that we watch an ed puzzle, we have to talk about, I'm trying to find my ending here. We need to talk about what if it was a system of inequalities. So I hope now that if you get ready, you're going to get your ruler, you're going to get your pencil, you're going to use graph paper, and we're going to do some graphing of inequalities. Have a great day, everybody.